All right. Here are the answers to the practice for the test, learning target number 2. Learning target number 2 is being able to use all of the exponent properties to simplify an expression that has exponents in it. All right? So I'm going to flash through the answers and then I'll talk about them. Okay, so I've listed all the rules up here. If you have questions about that, you should ask about them. I'm not going to go through them here. These are just kind of reminders of the rules we did. Here we go. So number 1, I am multiplying two terms together. When I multiply two terms, I multiply the coefficients, but I add the exponents. So I've got 1y and 1y, and when you multiply a single y times a single y, you get y squared. Number 2 is a multiplying problem. Again, I would multiply the coefficients. 2 times 3 is 6, but I would add the exponents. I've got 2x's and 5x's. That's a total of 7x's multiplied together. Number 3, another multiplying problem, so I'm going to multiply the coefficients. 4 times negative 2 is negative 8, but I'm going to add the x's, 3x's, and remember there's a 1 here, one more x, that is 4x's multiplied together. Finally, number 4 is another multiplying problem, so I would multiply the coefficients, 5 times 10, and get 50. But I would add up the exponents on the common bases. I'll start with the x's. I have 2x's here and one more x here. That's 3x's multiplied together. And I have 3y's and 3 more y's. That is 6y's. So my answer is 50 x to the third y to the sixth. Number 5, this 2 needs to be put on each thing in parentheses. So that would be 3 to the second, x squared to the second, and y to the second. Then you would go ahead and simplify that. Well, 3 to the second is 9. X squared to the second, since you have an exponent to another exponent, you multiply them and get x to the fourth, and the y to the second does not need simplified. Over here, I have a 3 on the parentheses, so that 3 needs to be applied to each thing in the product. That would give me 2 to the third, x to the third, and y squared to the third. And now you can go ahead and simplify that. 2 to the third means 2 times 2 times 2, so that's 8. X to the third is just x to the third. And here I have an exponent raised to another exponent, so you would multiply those together and get y to the sixth. Number 7. That's a pretty difficult problem. The first thing we need to do in 7 is do this part. We need to apply this exponent to its parenthesis. Then when we're done with that, we'll multiply times the second thing. So this would be 2 to the second, x squared to the second, y to the second. That's not very neat. But I can simplify that. 2 to the second is 4. X squared to the second, I have a power to a power, so I multiply them and get x to the fourth. And y to the second is just y to the second. I have now finished with the first term, but I need to multiply that times the second term. And when you multiply those together, you multiply the coefficients, the 5 times the 4, but you add the exponents, right? I have x to the fourth and another x, that's 5x's. And I have a y squared and a y to the fourth, that is 6y's. There we go. Number 8. Number 8, I need to multiply these together, and I need to multiply these together. So here I would multiply the coefficients. 2 times 3 is 6. And then I would add the exponents, right? 2x's and another x, that makes 3x's. A single y and a single y makes 2y's. Plus. Over here I would multiply the exponents. 5 times 2 is 10. I don't have any x's in the first term, but I have 3 in the second term, so it's going to be x to the third. And again, I have a single y and a single y, so that's going to be y squared. And then, because these are like terms, because they both have an x to the third and a y squared, they can be added together. And to add them together, you would add the 6 and the 10, but you would not change the like terms. And you would still have x to the third y squared. 16x to the third y squared. Number 9. Okay, the common mistake in number 9 is to try to multiply the 2's together and get 4. But 2 to the 7th is really just 7 2's multiplied together. Right? And 2 to the 5th is really 5 2's multiplied together. And so when I multiply 2 to the 7th and 2 to the 5th, I really have 12 2's all multiplied together. That would be 2 to the 12th, right? There's no 4 in there. It's 2 to the 12th power. Whew. Number 10. I have a fraction I need to simplify. So I would start by simplifying the coefficients, 6 over 8. You could do that on your calculator if you're not sure how. That would be 3/4. And then I start canceling out the x's. I have 2 x's on top and 1 x on the bottom. So when I cancel them out, I'm always going to end up with x's where there are more of them. And there's more of them on top. So I'm going to end up with x's on top, not the bottom. And however many extra there are on top, right? There's 2 x's on top and 1 on the bottom. So that's 1 extra x on top. So I have 1 x on top. The y's have the same amount on the top and bottom. So they both cancel out. There's no y's left over. And that's your answer. Number 11. The same as number 10, I'm going to start by reducing the coefficients. 5/10 reduces to 1/2. This problem has a single x on top and 3 x's on the bottom. So when I cancel those out, I have 2 x's left on the bottom. The y's, I have 3 y's on top. I have 2 y's on the bottom. So when I cancel out the y's, I've still got 1 y left on top. Number 12. Anything to the 0 power equals 1. So 12 to the 0 is 1. This entire thing is to the 0 power, so this entire thing equals 1. And that brings us to the negative exponents. A negative exponent means take the reciprocal. So I would take the reciprocal of the 5, and that turns the exponent positive. My final answer would be 1 over 5 to the second. Or if you want to make that 1 over 25, that would also be acceptable. I need to take the reciprocal of y, which would be 1 over y, and that turns the exponent positive. Number 16, you know, if you think about this thing as a fraction by putting it over 1, you now need to take the reciprocal of the thing that had a negative exponent on it. That's the b. So that means the b drops down to the bottom when you take its reciprocal, but the a stays on top. and you'd have a squared over b to the third. All right, now I have this fraction. So I'm going to handle it the same way I did on the front. I'm going to start by reducing the coefficients. 4/6 reduces to 2/3. Now I'm going to move the negative exponent. I'm going to take the reciprocal of the negative exponents, which moves them to the top or bottom. And then I'm going to see what I have left when I do that. So, this m on the bottom has a negative exponent, so he needs to move to the top. But the m on top has a positive exponent, so he's going to stay there. And essentially what I end up with is all 5 m's on top. So it'd be m to the 5th on top. The n's kind of go the other way. The one on top has a negative exponent, so he moves to the bottom, and that turns him positive. But the ones that were on the bottom are going to stay there. So I really end up with all 3 n's on the bottom. And that takes me to 18. In number 18, I see I have an exponent on a parenthesis, so I'm going to go ahead and apply it. That would be 2 to the third, x to the negative second to the third. Or when I simplify that, the 2 to the third would be 8. The x to the negative second to the third, I would multiply the exponents together and get, I would get x to the negative 6th. But now I can't finish with a negative exponent, so I need to go ahead and make this thing into a fraction and take this thing and do its reciprocal. So my final result would be 8 over x to the 6th. Number 19. Ooh, another fraction. It looks ugly. So I'd start by taking the 10 over 15 and reducing that. And now, let's start with the x's. The 5 that are on the bottom need to go to the top. The 2 that are on top need to go to the bottom. So the x's end up looking like that. 5 on top, 2 on the bottom. And so you're going to end up with x's on top. The only question is how many? Well, if there's 5 on top and 2 on the bottom, that's 3 extra on top. If you went to cross them out, you would end up with 3 left over on top. Let's go to the y's. The y's have this guy on the bottom needs to go to the top, but the 5 on top are staying there. So really, I end up with all 6 y's on top and none of them cross out. And last up, the z's. The z's don't need to go anywhere. There's 1 on top and there's 3 on the bottom. So when I go to cancel them out, I could just cancel out one of them, and that would leave me with 2 z's on the bottom. And we're done. Number 20. You cannot multiply these things together because they have different bases. The way you should do this is do 2 to the second power is 4, 3 to the second power is 9, and 4 times 9, 36. Number 21, 2x times 5x. This is very much like problem number 1. Multiply the coefficients and get 10. The x times x gives you x squared. When you add like terms together, you just add the coefficients, you don't change the variable. When you subtract like terms, you just subtract the coefficients and don't change the variables. And when you divide, we would do 8 divided by 2, that's 4 over 1. The x's, you've got 1x on top and 1x on the bottom. They would cancel out, leaving you with no x's. And there'd be a y on top. But 4y over 1 is better written 4y. All right, last up here. I'm supposed to write these in exponential notation. So that means leave an exponent on the answer. I just need to see if we know the exponent rules. Well, the rule is when you have a power to a power, you multiply them. So this would be 2 to the 18th. Here, when you have when you're dividing, you subtract the exponents. So this would be 15 to the negative 4th. But then I cannot leave a negative exponent. So that means take the reciprocal of the 15, and that turns the exponent positive. 2 rules in 1 there. Number 27, when I am multiplying, I simply add the exponents. So this would be 7 to the 16th. And a negative exponent means takes the reciprocal, and that turns the exponent positive. All right, good luck on the test.